Hello growers, I'm Dr. MJ Coco from CocoForCannabis.com. We publish articles, tutorials, and guides on the science and practice of growing cannabis. Today I have a truly exceptional light to test, the Photontek XT 1000W CO2 PRO. This is the first LED bar array fixture specifically designed and marketed for Ultra High PPFD in sealed rooms with supplemental carbon dioxide. It's a true 1000-watt LED grow light, and it puts out twice as much usable light as a 1000-watt HPS. It is ultra efficient and generates very little heat, which allows it to find a home in sealed rooms that rely on air conditioning. But with 10 removable LED bars, it offers flexibility for growers with and without a sealed room or CO2. Photontek is the sister company of Lumitech EU, a European horticultural lighting company with an excellent reputation. The Photontek X series fixtures are sold in Europe as the Lumitech Zeus. I reviewed the Photontek X 600W Pro in August 2020. It performed exceptionally well and has earned rave reviews from growers. The XT 1000W CO2 Pro is the newest addition to the series. As I will explain, it's a revolutionary fixture. In this review, I'll do an unboxing and show the simple assembly process. I'll run it through a CO2 PAR test with a maximum PPFD at 1500 micromoles per square meter. Since CO2 grows are in sealed spaces, I analyze the total heat output along with the total light output. I compare the XT 1000W CO2 Pro to HPS fixtures and consider the most efficient way to generate ultra-high PPFD while keeping a sealed room cool. If you have a sealed space with CO2, Photontek designed this light for you. And growers without supplemental carbon dioxide can run it in a larger space, slightly dimmed, or without all the bars. I'll run 2 additional tests with a maximum PPFD set to 1000 micromoles per square meter. One test at 75% power, and the other with only 8 of the 10 bars. These tests produce the best PAR maps I have ever seen for a 5x5 space with normal levels of carbon dioxide. It may be overkill for many growers, but in my opinion, the Photontek XT 1000W CO2 Pro is easily the best fixture for spaces 5x5 and above. After we analyze the test results, I think you will agree. Grow light PAR testing is part of the Coco for Cannabis Grow Light Guide. Our goal is to educate growers about horticultural lighting. You can read our grow light articles, try the grow light calculator, browse the grow light test reports, and find all our grow light discount codes. You can save 5% on Photontek products with discount code Coco, PTK5. You support our work when you follow our links and use our discount codes when you shop for grow lights. The Photontek XT 1000W CO2 Pro arrived in this big, bold, beautiful box. They do also offer a discreet shipping option. They make some bold claims, but I agree that it is the most powerful LED grow light on the market designed for 5x5 coverage. I'm excited to check this one out. Wow, nice bars. A lot of them. The Photontek X series feature removable LED bars. Very high quality build. I'll take off the protective cover and we can see the diodes. Lumitech Photontek were the first to develop a removable bar fixture as an upgrade to foldable LED bar arrays. Other companies are following their lead. I've tested several new lights that use a similar design. And through time, I expect to continue to see more and more brands move away from foldable lights and copy the superior design of the Lumitech Zeus and Photontek X series. Below the 10 LED bars, we have the power cord in this bag. This is the little hanging kit, and this is the dimmer controller. The driver is under here, but let me take out the frame pieces first. This piece has the cables and connectors. You can see the magnet circles where each LED bar attaches. The second frame piece does not have cables or magnets. The LED bars just clip in. They provide a user manual, and then the main chassis with the driver. I'll spread it all out so we can see everything that we got. Okay, we have a sea of LED bars. 10 of them. I got the frame pieces set on either side. You can see the central chassis with the Photontek driver mounted on top. There's the power cord and the dimmer controller, and we have the second frame piece. Let me take a closer look at the driver. The driver is a large Photontek driver. Remember that Photontek is the sister company of Lumitech, and they've made high-efficiency drivers and ballasts for years. This is a top-end, very highly efficient driver. It is segmented for each bar. That means you can run the fixture with anything from 1 to all 10 bars. This feature gives the XT 1000W CO2 PRO incredible flexibility. Photontek uses top-end diodes from LumiLEDs and OSRAM. Each bar has 288 LumiLED full-spectrum diodes, model 3030 HE+, and 24 OSRAM 660nm diodes, version SQ 3.24. There are 10 LED bars, which gives the XT 1000W CO2 PRO a total of 3,120 diodes. With 1,000 watts, that's 3.12 diodes per watt. On the other side of the bars, there's a clip at one end. You can see the aluminum fins, which quickly dissipate the heat, and at the other end you see the magnet, which will hold the bar in place. To build the frame, we just click the frame pieces into the central chassis. Each frame piece has clips, and they slide into the ends of the bars on the central chassis. With the frame complete, we just have to add the bars. The clip goes into the holes on one side, and the magnets clip together on the other side. Photontek was the pioneer of removable bar fixtures, and they are still the leader. The build quality is exceptional. Everything fits together perfectly, and this magnet design is elegant and easy to use. You can see the magnets here that click together, and the electrical connections that are made. But first, on the other side, I have to hook the clip into the hole on the frame. Then I lower the bars and the magnets click together. It's a secure connection, and the assembly is basically complete. It's an impressive looking fixture with all 10 bars. I'll flip it over. We can see the equally impressive Photontek driver. It can stay there, or you can get longer cables and detach the driver. I'll use 4 ratchet pulleys to hang it up. There are 4 eye bolts on the center chassis. With the driver and 10 bars, it is a substantial fixture. But if the weight or bulk is a concern, you can just hang up the frame and add the LED bars when it's already hanging in place. I still have to attach the cables. There are 3 cables coming from the frame that need to be plugged into the driver. They're all nice self-twisting connectors. Line them up and push them on. Then I have to plug the controller into the port on the frame. And finally, on the other side of the driver, I'll attach the power cord. I plugged it in, let me flip the switch, and we have light. Let's take a good look at the diodes. There are a ton of diodes putting out an incredible amount of light. Along each bar you can see the 2 rows of the full spectrum LumiLEDs, and spaced among them along the center are the OSRAM 660nm chips. The 10 bars are evenly spaced along the frame, and they seem well prepared to blanket the coverage area with high density light. The engineers at Photontek designed the XT 1000W CO2 PRO to deliver Ultra High PPFD up to 1500 micromoles per square meter to a 5 by 5 foot area. I discussed the fixture with them during the development phase and was impressed. They considered the photon densities required to take maximum advantage of supplemental CO2, and because CO2 grows are in sealed spaces, they also paid close attention to the total heat output. I'm excited to test it, but we have to let the diodes warm up first. Let's take this quick moment to check out the Photontek website. This is the product page for the Photontek XT 1000W CO2 PRO. You can see that it's sold in Europe as the Lumitec Zeus 1000W Extreme PPFD CO2. The list price is $1,599, but we have a 5% discount code for Photontek. Shop photonteklighting.com and use discount code Coco, PTK5. I love that they put a legitimate total PPF value here as a main selling point. If we scroll down the page, we'll find other important data. They claim an efficacy of 2.9 micromoles per watt, which agrees with the PPF of 2,925 micromoles. Like many LED drivers, it can be powered with 120 to 277 volt input power. Photontek advises that it will draw 1,025 watts at 120 volts, which is how I will test it. Let's take these data and run them through the Coco for Cannabis Grow Light calculator. This is our tool to help growers analyze grow lights. In the calculator on the right, we load all our tested fixtures. And in the calculator on the left, you can enter your own data. I'll enter the data about the Photontek XT 1000W CO2 PRO. At 120 volts, the power draw is listed at 1025 watts. If you use discount code Coco PTK5 on the Photontek website, your cost will be about $1,520. And then we need to enter the PPF data. Photontek provides sphere-tested PPF data, so I need to select Total PPF. They list the total PPF at 2,925 micromoles. Okay, yeah, these are some really great numbers. We estimate a usable PPF of 2,532 micromoles had an efficiency of 2.47 micromoles per watt. That gives it a cost efficiency of only 60 cents per micromole. But an important note, I designed the formulas behind the calculator for normal grows without supplemental CO2 and with a maximum PPFD of 1,000 micromoles per square meter. You can see the calculator is rating it for 39 square feet, which is one application for this fixture. You could easily light a 6 by 6 foot space with excellent density light for a no CO2 grow. But the Photontek XT 1000W CO2 PRO is specifically designed for a higher PPFD limit in a 5 by 5 space. The efficiencies and harvest potential will be slightly lower than these estimates in the smaller space, but the XT 1000W CO2 PRO will allow you to maximize production in that footprint. I have it set up in the 150 by 150 centimeter test area, which is just about 5 by 5 feet. The maximum PPFD is right at 1,500 micromoles per square meter. The hanging height is 52 centimeters, about 20.5 inches, and the fixture is centered and square. It's time for a test. I use an Apogee SQ500 quantum sensor to measure the PPFD, or photon density, in each square in the grid. There are limits to the density of photons that plants can safely use for photosynthesis. In most indoor grows, carbon dioxide levels determine the maximum safe PPFD. With ambient levels of carbon dioxide, the maximum safe PPFD is 1,000 micromoles per square meter. In a sealed space with elevated levels of carbon dioxide, the PPFD limit can be up to 1,500 micromoles per square meter. Most LED bar arrays are not capable of producing a photon density that high with an even distribution. LED fixtures have typically been designed for ventilated grow spaces where the PPFD limit is lower. High-intensity discharge, HID lighting, like high-pressure sodium, HPS, is still dominant in sealed rooms running supplemental carbon dioxide. But that may be about to change. I'm impressed with the numbers I'm recording. Let's check out the PAR map from this CO2 PAR test. You can see the incredible density of light. In the center, there's a lot of area above 1,400 micromoles per square meter. A third of the map is in the Ultra High PPFD range above 1,200 micromoles per square meter. More than half of the map is above 1,000 micromoles per square meter. Indeed, there are values at or near 1,000 from top to bottom and edge to edge. Perhaps most impressive, the density does not drop off much into the corners. The lowest corner is still in the maximum production zone at 719 micromoles per square meter. It is an exceptional PAR map because the XT 1000W CO2 PRO produces a ton of light and distributes it very well across the 5 by 5 canopy. Let's run the numbers. The hanging height was 52 centimeters, about 20.5 inches. At that height, the maximum PPFD was 1,500 micromoles per square meter, which is the upper limit that we recommend for CO2 grows. The average PPFD was way up at 1,079.6 micromoles per square meter. That means the Photontek XT 1000W CO2 PRO delivered 2,429.1 micromoles of usable light to the canopy. This is a really impressive number. It's more than twice the amount of light generated by a typical 1,000W HPS bulb. The XT 1000W CO2 PRO had a power draw of 1,012 watts during the test, which gives it an incredible 2.4 micromoles per watt. It is among the most efficient LED grow lights on the market. To take advantage of the ultra-high density light that the Photontek XT 1000W CO2 PRO can deliver, growers must seal their grow spaces and elevate the carbon dioxide levels. Sealed rooms without exhaust need to be cooled with air conditioning, This adds considerable expense, which needs to be considered in the total efficiency of the system. Efficient LEDs put out less heat per micromole of light than HPS and other HID bulbs. However, HID bulbs can be run in air-cooled hoods, which remove about 80% of the heat that they generate. Because of this, many growers believe that air-cooled hoods with HID are the most efficient way to light a sealed space that relies on air conditioning. This is no longer the case. I analyzed 3 different grow light options for sealed spaces in terms of light, heat, cooling, and system efficiency. I compared the Gavita 1000 watt double-ended HPS with an open reflector, iHortolux 1000 watt single-ended HPS in an air-cooled hood, and the Photontek XT 1000 watt CO2 PRO. 2 of the Gavita HPS will deliver a usable ppf of 3032 micromoles. 2 of the iHortolux HPS will deliver 2244 micromoles. And the Photontek is about twice as efficient. So only one XT 1000 watt CO2 PRO will deliver 2429 micromoles. The usable photon efficiency is striking. Our friend Shane from MyGrow tested the Gavita system at 1.47 micromoles per watt. The iHortolux single-ended HPS will get only about 1.1 micromoles per watt. And as you just saw, I tested the Photontek at 2.4 micromoles per watt. So to get a similar amount of light, we need to run 2066 watts through the Gavita, 2040 watts through the iHortolux, and only 1012 watts through the Photontek. But what about heat? I got the published BTU data from each manufacturer. Each Gavita bulb generates 4000 BTU, so 8000 total. Each iHortolux bulb generates 4600 BTU, or 9200 total, but the single-ended bulbs can be run in an air-cooled hood, which can pull about 80% of that heat away. The Photontek XT 1000 watt CO2 PRO generates less heat than either HPS bulb. With the driver attached, it generates 3497 BTU. Now we have to consider the cooling power needed to offset the heat. A good air conditioner can cool 10 BTU per watt, so we would need 800 watts of air conditioning for the Gavita system. The iHortolux system needs only 184 watts for air conditioning, but we also have to add about 100 watts to run the fans for the air-cooled hoods. And the Photontek system requires about 350 watts of air conditioning to completely offset the heat. Considering both light and air conditioning, the total power needed for the Gavita system is 2,866 watts. That equates to a system efficiency of 1.06 micromoles per watt. The iHortolux and the air-cooled hoods use less power overall with 2,324 watts, but they also produce less light. So despite the savings in cooling, the system is less efficient, with only 0.97 micromoles per watt. The Photontek XT 1000 watt CO2 PRO crushes both of these. It requires a total power of only 1,362 watts to light and cool the grow space, which means it has a system efficiency of 1.78 micromoles per watt. It's about 80% more efficient than the HPS systems. You can find this chart, along with my notes and sources, on the test report page. The Photontek XT 1000 watt CO2 PRO is the most efficient option for ultra high PPFD in a sealed space with air conditioning. But what if you grow in a ventilated space without supplemental CO2? There are several ways to use it in grows with normal levels of CO2 and PPFD. Of course, you could put it in a larger area. It will easily cover a 6x6 foot space, but I don't have a 6x6 foot test area. In a 5x5 space without CO2, growers could run the XT 1000 watt CO2 PRO slightly dim or remove some of the bars. I'm going to test both of those options. For this next test, I set the dimmer to 75%, and I raised the XT 1000 watt CO2 PRO to 67 centimeters, about 26.5 inches. The maximum PPFD is now 1,000 micromoles per square meter. I'm just making sure it's still centered and square, and we're off on another par test. Wow, I can already tell that this is going to be an amazing par map. If you have to run a fixture dim like this, then you may feel like you're not getting the full benefit. But there are actually several advantages to running a large fixture dim if it can still produce the density that you need. Dimming lowers the current through all of the diodes. This makes them more efficient and increases their longevity. The distribution of light should be excellent because the diodes are well spread out in the array, and in this case, the fixture is hung really high. The XT1000W CO2 PRO is overpowered for this application, so it's certainly not going to be the lowest cost fixture for a 5x5 without CO2, but I think it will offer the best possible coverage. This is a crazy good PAR map. Let's check it out. I have tested a lot of LED bar arrays designed for 5x5 coverage. This PAR map puts them all to shame. The vast majority of the canopy is in the maximum production zone from 700 to 1000 micromoles per square meter. Most 5x5 fixtures can't get good density light into the corners. Many can't even get the corners up to 400 micromoles per square meter. The lowest corner in this map is way up at 618. The Photontek XT 1000W CO2 PRO at 75% power smothers the 5x5 area with high density light from corner to corner. Let's run the numbers. At 75% power, I had to raise the Photontek XT 1000W CO2 PRO to 67 centimeters, about 26.5 inches, in order to lower the maximum PPFD to 1000 micromoles per square meter. The average PPFD was 797.8 micromoles per square meter, which means it delivered a usable ppf of 1,795.1 micromoles. The power draw was 753 watts, so in this setup, the Photontek XT 1000W CO2 PRO had a usable photon efficiency of 2.38 micromoles per watt. In a 5x5 foot space, corners above 600 with an efficiency of 2.38 is incredible. The 75% test is a winner. And there's another way we could possibly make an even better PAR map. Instead of dimming the fixture, I can remove 2 of the bars. For the best distribution, I'm going to leave 3 bars at each end and 2 bars in the middle. I'll remove the 4th bar and the 7th bar. They just pop off the magnets. I'll put the dimmer back to 100% and turn it back on. I really love this feature of the Photontek lights. The ability to remove bars adds a lot of flexibility. The driver adjusts automatically to any number of bars. Here with 8 bars, it's drawing exactly 800 watts. It's a little more power than in the 75% dimming test. And with the bars spaced out like this, I expect an even better distribution. I gave the diodes enough time to warm up again. It's time to find the hotspot and set up the fixture for this test. With 3 bars together on the end, I'm curious if the hotspot will be off-center, but it doesn't seem to be. The highest PPFD is still here, right in the center. Interestingly, it's a little under 1000 micromoles per square meter. I have to lower the XT 1000W CO2 PRO a couple of centimeters. This is actually a good thing. It's drawing more power than at 75%, but it can be hung a little lower. That's confirmation that the distribution is going to be better in this test. I'm making sure it's still centered and level. It only required a 1.5 centimeter adjustment. The hanging height is 65.5 centimeters, about 26 inches. The maximum PPFD is exactly 1000 micromoles per square meter. And wow, that first corner was 681. When I dimmed all 10 bars in the last test, it reduced the amount of light everywhere. In this test, I removed 2 bars, which reduced the amount of light primarily in the center. So now there are 3 bars at each end. They're at 100% power instead of 75%, and they're slightly closer to the canopy. This is getting more light out to the corners, and the density of light in the middle is still right at the 1000 micromole per square meter limit. It may seem silly to buy 10 bars and only use 8, but if you want the absolute best PAR map for a 5x5 foot space without supplemental CO2, I think this is going to be it. It is certainly the best 5x5 PAR map that I've seen. Let's check it out. This is a phenomenal distribution of high density light. I'll add these arrows along the edge to show the placement of the bars and the 2 bars I removed. You can see that removing those bars had no significant effect on the PPFD in those rows. In the center, there's a huge area of 900 plus PPFD values. There are 800 plus values from top to bottom, and there is excellent density light everywhere. The lowest corner is way up at 652 micromoles per square meter. In a 5 by 5 foot area, that's almost unbelievable. Let's look back at the 75% PAR map. Of course, this is also an excellent PAR map, but you see the corners are lower. And there are a few more squares in the corners on the right that are just below 700 micromoles per square meter. With 8 bars at 100%, the PAR map is just a little bit better. But the efficiency is going to be just a little bit lower than the 75% test. Let's run the numbers. With the 8 bars at 100% power, I had to lower the XT 1000W CO2 PRO to 65.5 centimeters, about 26 inches above the sensor, to keep the maximum PPFD at 1000 micromoles per square meter. The distribution is phenomenal, so the average PPFD is 822.2 micromoles per square meter. This equates to a usable ppf of 1850 micromoles. The power draw was exactly 800 watts, so the efficiency is slightly lower, but it's still exceptional at 2.31 micromoles per watt. The decrease in efficiency is because diodes are more efficient when dimmed. 75% power is more efficient, but 8 bars at full power creates an extraordinary distribution of light. If you want to check out these maps and data, I publish complete test report pages as part of the Coco for Cannabis Grow Light Guide. They include all the data and maps from the PAR tests and my written review. Here are the main data from the official CO2 PAR test. You can find our discount codes and shopping links. Remember, you get a 5% discount at photontechlighting.com with discount code Coco PTK5. That will make your price about $1,520. That's only 63 cents per micromole, which is a great price for this fixture. Below this area, you'll find the detailed PAR test data and the PAR maps. This grow space calculator assumes the PPFD limit will be 1000. So if you're running PPFD up to 1500, just calculate 1 XT 1000W CO2 PRO per 25 square feet. Down here, you'll find my written review. As a brand, I give Photontek my highest recommendation. They make top quality fixtures, and they stand behind them with one of the best warranties in the industry. They do their own research and development, and they have brought several great innovations to the market. The new XT 1000W CO2 PRO is revolutionary. Its flexibility, power, and efficiency are exceptional. It's capable of filling in a 5x5 PAR map like no other fixture on the market. But it is the fact that they designed this LED bar array to be run in sealed rooms that's revolutionary. It produces so much more light and so much less heat than HPS. Even though you can't put it in an air-cooled hood, it still crushes in terms of total system efficiency. I think it's clearly the best fixture on the market for sealed rooms with supplemental carbon dioxide. If you have more space and sufficient hanging height, then you could run this light at 100% power without supplemental CO2. I estimate that it would perform well in a 6 by 6 foot space at a hanging height of about 80 centimeters or 31.5 inches. As we saw, you can also put it in a 5 by 5 tent without CO2. The 75% dimmer test and the 8 bar test produced amazing results. You cannot get better 5 by 5 PAR maps than that. Growers often ask me, what's the best grow light for a 5 by 5 space? I have an unequivocal answer now. It's the Photontek XT 1000W CO2 PRO. You may not need all of this light. You may not even be able to use all of this light, but there is no other fixture that offers as much power and flexibility. My colleague Dr. Photon is so impressed with it that he got one for his personal grow. Using it ourselves is the most significant endorsement we can give to a grow light. At Coco for Cannabis, we always put the grower's interests first. Our goal is to provide impartial, science-based testing and reviews for home growers. We do not get paid for testing lights, but we do earn commissions when you make purchases using our codes. You can support our work simply by using our discount codes when you purchase grow lights. I'd like to thank our team at Photontek for sending me the XT 1000W CO2 PRO to test. And thank you for watching. Please give the video a thumbs up and subscribe to my channel. Check out my other par test reports and grow light physics videos. And I hope you come to visit us at cocoforcannabis.com. You can read our articles, chat with our community, browse the grow light test reports, and try your hand at the grow light calculator. You can win grow lights by participating in our grow challenges and strain review giveaways. Grow your own, but don't grow alone. Let's grow together. I'm Dr. MJ Coco, sending all of you grower love.